Cynthia Brain, and I want to welcome you to the Advanced Evidence-Based Undergraduate STEM Teaching course. The goal of this course is to help you better understand evidence-based teaching practices that you can use to help your students learn the skills, the ways of thinking, and the content of your disciplines. The course builds on the Introduction to Evidence-Based Undergraduate STEM Teaching course, and we recommend that you work through that course before doing this one. It's certainly not required, but the principles of learning described in the first course provide a strong basis for thinking about the teaching approaches that we're going to explore in this course. Now, I'm really excited to share the teaching and learning approaches in this course with you. I'm currently an assistant director at Vanderbilt Center for Teaching, where I help STEM faculty think about how to incorporate evidence-based practices into their own teaching. In addition to that role, however, I also teach biochemistry in the biological sciences department. And before I came to Vanderbilt, I taught genetics, cell biology, and other biology courses at Centenary College of Louisiana. And really, the reason I'm excited to share the approaches in this course with you is because of that experience. My experience watching my students learn and grow when I started using these approaches. I remember distinctly the first time I tried using an active learning approach in class where I asked my students to work together, and how exciting it was to see their engagement and to hear their ideas develop. And my experience is not anomalous. The research bears it out. A particularly notable study was published by Scott Freeman, Mary Pat Wenderoth, and colleagues in the Proceedings of the National Academy of Sciences in 2014. So in this study, they did a meta-analysis looking at 225 studies that compared student performance in classes with just lecture, which they defined as continuous transmission of information by the instructor, or in classes with some active learning, and they didn't define how much. They found that student performance was much stronger in courses with some active learning, whether they looked at performance on standardized measures of learning like concept inventories or course grades. And in fact, they found that students were 1.5 more times more likely to fail in traditional lecture courses than in courses with some active learning. And they noted that had this been a clinical trial, it would have been stopped to avoid the negative consequences of the traditional approach. It's a pretty compelling article, and I encourage you to read it if you haven't yet had a chance to do so. So in this course, we're going to consider several approaches for incorporating active learning. We'll start by talking about peer instruction and problem-based learning, both of which are active learning approaches that provide students opportunities to practice key skills and get targeted feedback. We'll also talk about inquiry-based labs and how they help students develop important skills of scientific thinking. Those three approaches all involve students working together in learning communities, and they're most successful when we're inclusive and consider ways that we can leverage the diversity in our classrooms. So the next two modules in the course explore the ideas of cooperative learning and learning through diversity. Finally, we explore the flipped classroom as an approach to course design that can help us incorporate some of the approaches that we've discussed. So to help you think through these ideas and figure out how to incorporate them into your teaching and really make them your own, our final assignment in the course will be a statement of teaching philosophy, in which we'll ask you to articulate how you'll incorporate the techniques and strategies from this course into your own teaching practice. This course was developed by the Center for the Integration of Research, Teaching, and Learning, or CIRTL, which is a consortium of universities focused on developing a future STEM faculty, that is, faculty teaching science, technology, engineering, or mathematics courses. So future STEM faculty who are well-versed in evidence-based teaching practices. The course was developed by a team of STEM educators from across the country, and it highlights 3 core ideas from the BUXCIRTL network: the use of learning communities, learning through diversity, and teaching as research, defined as the deliberate, systematic, and reflective use of research methods by STEM instructors to develop and implement teaching practices that advance the learning experiences of both the students and the teachers. So again, welcome. I'm excited to have you join us in this course. Before we begin, I want to note that many participants in the course also participate in local learning communities or groups of participants who meet regularly during the course to discuss what they are learning. This can be a particularly valuable way to think through the ideas within the course, and I encourage you to consider finding or starting your own local learning community. If you want to do that, visit stemteachingcourse.org for ideas. Now, let's get started.